Hey everybody, today we'll do another video, and today we will do what is called phasors in AC analysis. AC analysis. Right? So the problem states that we have to evaluate a complex number, and we will have to leave the result in a polar form, right? So this is the book that I'm using. I'm using the Fundamental of Electric Circuits. So if you're using the same number, so we're doing problem 9.9, right? So 9.9. If you're using the same book, we can follow. But if not, it's going to be, it's going to be pretty much the same process anyway. Okay, so the problem says that we have a 5. We have 5. We have angle 30 degrees. We have parenthesis. We have a 6 minus 8j. And then we have a plus 3 angle 60 degrees on top, right? And then we have in the bottom of that we have 2. We have a 2 plus j. Right? 2 plus j. So basically, we have this. So we have a lot going on here. This is not an easy problem. I mean, you can plug in the calculator. If your teacher wants you to show you work, then yeah, unfortunately, you have to do a lot of work. But if you have a calculator, scientific calculator, you plug in the numbers, you will give a result in polar. But we will do this showing the work. So basically, step 1, step 1, I have to convert that into this form, right? And that one also into this form of complex. Because right now I have a phasor, and also I have a complex number. So I can't really just, multiply or add anything like that. So I have to do 5 cosine of 30 degrees, right? Plus j sine of 30 degrees, right? When I do that, and also unfortunately we have to use a calculator in this, right? So it's another thing. So we do 5, and then we do cosine of that. So we do cosine of 30, right? And that is equal to, the cosine gave me 4.33, right? Then we do the sine part of that, right? And we do the sine, and we do 5 times 30, 5 times sine of 30, and that gave me plus j, right? Because I got to do the j. This is the complex part of it. I got to do the j with the sine, so 2.5, right? Next, we do this, right? So next we do 3 cosine of 60 degrees plus j, right? So remember here I'm doing also the 3. the 5 here, right? And also over here, to make it clear, you can put parentheses here, right? And do the same thing, but, you know, it's up to you how you want to do it. Doesn't matter. I mean, so right here, I will say 3J, right? Sine of 60 degrees, right? And that will give me what? That's going to give me 3 cos 60, right? That's going to give me 2.6. Actually, no, that was the sine, right? So never mind. So, okay, so 3 sine of 60, right? That's 1.5. And I do 3 sine of 60, which I already had the number, but I will do it again. It's plus J 2.6, right? Now I have it those, right? So I have this in rectangular form, right? I have it in rectangular form. Now we have to work this out, right? So how we are going to do that, right? So basically, I have to write everything, and I have to say 4.33 plus 2.5J, right? And over here, I gotta have 6 minus 8J, right? And I have to add a plus sign in that, and I want to go ahead and add whatever was on the top of this guy right here is going to be 1.5 plus J 2.6, right? And then, so that is part of that's what we're doing, right? So we converting everything. So now I put this guy up here, down here, which is 1 minus 1 plus J, right? 1 plus J. So now we have to do more work, unfortunately. So remember that we have this denominator here. We have to get rid of it. And the way that we get rid of that denominator is by doing the following. So we do the following. So we say that I will put this part right here because it's going to require a little work, right? Separate. So I will just make sure that I bring this part right here somewhere, and I will say 1.5 plus 2.6, right? J, right? And over here you do 2 plus J, right? Now it's going to have, we will do conjugate, right? We call it multiplied by the conjugate. Multiply by the conjugate. Okay, so now right here I gotta do the opposite, right? So I gotta do 2 minus J on both sides, top and bottom. And I gotta do 2 minus J and multiply this guy by 2 minus J. When I multiply the top by 2 minus J, I get the following. So I get that. So it's going to be a 3 on top, right? And then it's going to be minus 1.5J, right? Minus 1.5J, right? Doing these two guys. And then I got to do the bottom. I'm sorry, not the bottom, but So that is equal to, so this, right? This equal to 2 plus, okay, so plus 5, okay, plus J 5.2, right? Now I gotta do the last one, right? I gotta do the last one. And when I do the last one, I get minus, I get minus J squared, right? Because I'm multiplying this J with this J, right? So that is minus J squared 2.6. Now, once I have this, look that I can combine this J and that J, right? So I got right here, I got 3 plus, right? Combine these two guys, I get 3.7 J, right? 3.7 J, right? Minus J squared 2.6. Now, this is only the top part, right? But I gotta do the bottom part of this. And when I do the bottom part of this, I do 2 plus J times 2 minus J, and I get 4, right? I get 4, and then I get 2, and I get plus, minus 2J, right? Minus 2J, right? And then right here, I get plus, and then right here I get plus 2J, plus 2J, and I get over here minus J squared, right? Now, remember the J squared is equal to -1, right? By definition of the imaginary numbers, right? In electrical, that's what we use. We use the J. We don't use electrical engineering. We don't use the I, right? So now I plug that here, and this guy cancel, and I get 4, and then I get a minus and a minus, right? And because that is a -1, right? That guy is a -1 right there. So it's going to be a 4 plus 1, which is equal to 5. Right. So the bottom is equal to 5. And that's the whole purpose of doing this, right? So right here, I should have 5. Right there. Now look that this is not done yet, because on the top, I should add J squared is equal to -1. When I put J squared over here, that becomes a positive, so that becomes -1 squared, right? But I got a negative 2 in front of it, and then times 2.6, which is 2.6, right? So that is 2.6 right there. So in other words, this guy becomes that 2.6, right? And then I can rewrite that as adding that 2.6 to this, right? Is going to be equal to 5.6. So it's going to be 5.6. Yes. So it's going to be 5.6 plus that 3.7 J over 5. Right. So now notice that I have that, right? So now I take that number and divide everything by 5, and I get this simplified to 1.12 plus, so plus 74 plus J 0.74. All right. So this is, it requires a lot of pieces of work, but okay, it is what it is. So we don't have a choice but just do it, right? So now we can actually do that. So now I simplified this piece, right, which is becomes that. Now I can put it right here, right? So now I can do 4.33 plus. I am bringing this guy, right? I already simplified that, which became that, right? I am putting, instead of having this mess right here, I will put it right, that 1.2 plus J 0.74, right? I'll put it right there. So you guys tracking what I'm doing. So then I have 2.5 J, right? 2.5 J here. Right. Now I have what? I have that guy, which is 1.2 plus, but you gotta be careful. So let me just do it step by step. So right here, so 0.5, right? Put a parenthesis on it, right? And then 6 minus 8J, right? Plus that guy, which is 1.12 plus 0.74 J. Okay, now as you can see that I can add this guy, right? So I can add this to this, and I can add this to this. So I got 4.33 plus J 2.5, right? Plus J 2.5. Then I have it right here. I got that. So I got 7.12, right? This one, right? And this one, right? And then I gotta do this and this, which is minus. If I add those two, it's going to be a minus 7.26 J. Right. So that is, those guys are done now, right? Now we have a new problem here. Now we have to do more, unfortunately. So we need to multiply this. So we need to do 4.33 times 7.12 is going to be equal to 30.83, right? Then I get 7.26 times 4.33 is equal to negative J 31.44. Right? Now I did this and I did this. Now we gotta do this, right? This and this, right? So now I do that, and that is equal to plus. So I do plus 2.5J times 7.12 is equal to J 17.8, right? Now I do this times this, and I can see that I need a minus sign, so I'm going to go ahead before I forget to put it over there. So it's going to be 2.5 times 17.26. Actually, no. 2.5 times 7.26 is equal to negative 18.15, right? And it's a J, and remember, I have a J here and J here, and that becomes J squared. Okay, so we had to do more work, unfortunately. Unfortunately. So right here, as you can see, I have this, right? So I can actually add 31.44, and then that is a negative, right? And then I subtract that 17, or I add 17.8, and that becomes 30.83 minus, because a minus, it's going to be that graded, this is greater than this, so it's going to be 13.64 J. Now I have the J squared 18.15 there, right? So now I do what I do. So what I do now, I replace again, I squared is equal to -1. So when I do that, that becomes 30.83 minus 30.64, right? That's a J. Plus, that becomes a plus now, right? Because I add a negative, I put a negative there, and and that becomes a positive right there. So that becomes 18. So 18.15, right? So when I add that 18.15, of course that's going to be just 48, right? So it's going to be 48.15, right? So this guy is done, right? This guy is gone now. I just have right now a number, right? A pure number, and I still have a J, unfortunately. But I gotta do right here is now it's easy because all we have to do is last step. So got a 48.15 plus or minus J 0.1, J 1364, right? So now we have a single polar, right? Or rectangular, I'm sorry, single rectangular. So now we have to do more work. More work. So more work. So let me just do this quick here. So now we have 48.15 and we have minus J 13.64. Right. So now we need to find the angle of that, right? So because we give it we have to put this answer in a polar form. So we need the angle, right? So we need the angle and also we need the magnitude. Remember magnitude. So we use theta is equal to tangent inverse of y over x, right? This represents the sine and this is the cosine. So might as well do y over x, or sine over cosine, right? That is the inverse, right? So it's going to be negative 13.64 over 48.15, right? And that is going to give me the angle, right? That I'm looking for. So I take that and I say inverse tangent. So negative 13.64 over 48.15. It is equal to negative theta is equal to negative 15 degrees 0.8, right? So now we have something, right, to work with. Now we have to do more work, right? So we have to find the magnitude of these two guys, right? And how we do that? So we do the magnitude is equal to what? Is equal to x squared plus y squared, right? Right. So right here is going to be the magnitude of that is going to be equal to this is cosine to represent the x, so this is the sine guy to represent the y. So therefore, it's 48.15 plus negative 13.64, right? And then squared, right? So when I do that, I get 48.15 squared plus negative 13.64 squared, right? Okay, so let's see. Okay, so 48.15 plus negative 13.64, right? So this is, right? So let's do this again. So 48.15, right? Is square plus 13.64, right? And then I take the square root of that, and that is equal to, the magnitude of that is equal to 50. All right, so that's the number, right? I was entering and kind of, I guess, I am not really used to this little calculator, so yeah. But anyway, so that's how we do that, right? Now, so the final answer is going to be, for this is going to be what? It's going to be 50 angle 15.8 degrees. And that will be the answer for that. It's a lot of work, but it can be done. It's one of those things that unfortunately you want to work it out by hand. It's going to take a little while to get problems like this done. But anyway, so I guess that's it for today. If you learned anything, please let me know, and I see you in the next video. Thank you for watching.